Welcome back to a follow-up video about how to push software onto an ESP32 board. Please feed the YouTube algorithm by giving the video a like. If you want to see more like this, click subscribe and ring the bell to be notified of new videos. If you want to chip in on my expenses, I now have Patreon and YouTube memberships. I want to give a quick shout out to my new sponsor, PCBX. It's a circuit board and board assembly company, which turns out is right on the mark for me. I saw a post for their Facebook page and was interested in their capabilities, so I joined the group. PCBX isn't as well known as some of the other circuit board companies, but they've got the facilities to compete with up to 8-layer boards, 2-sided SMT assembly, and over 200,000 parts in their catalog. They also offer their own design tool, but can accept native files from KiCad, Altium and Eagle, and of course, standard Gerber files. The interesting thing for me is that they happily support people like me who only need prototypes and low volume orders. Their circuit board prices are about the same or a little cheaper than the others, but they say their board assembly has better quality at a lower price. As a new customer, you have immediate access to great prices and big discount coupons for boards and assembly services. To top off the partnership, I hope to visit their Shanghai factory this winter and make a great video so everybody can see their capabilities. So be sure to check them out the next time you're uploading a board design. So we're going to try 3 different things today which are interrelated. The first one is we're going to try to upload software to the board over the USB-C port and monitor the debug responses that come back. The second one is we're going to try to upload it over the air with no cables simply by using a Wi-Fi connection. And the third part is we're going to try and get debugging messages back from the board again over a Wi-Fi connection with no cables required. So let's see what happens. In the last video, I explained how to do it with the hardware debugging board, the ESP-PROG. Went into gory detail about that. This time I'm going to give you a couple of alternatives. One being the much simpler strategy of simply using the serial port capabilities of the board to both flash firmware and to get your debugging messages back out. Now you can't do hardware debugging over this because there's just not enough circuitry and smarts in there to single step the processor and get, extract all of the variable values and all of that. But for somebody who's just looking for the simplest possible way to push firmware into the chip and read the messages back out, then this is the video for you. So I'm using my same Blinky sketch, and if we go back to the PlatfomIO.ini file, this is where all the critical stuff happens. I've commented out all the lines that deal with the ESP-PROG board configuration, and I've just added the ones I need for the serial port. In my case, my USB-C connector is on COM3, and I can tell that via the Windows Device Manager because I have a Silicon Labs CP2102N UART bridge in that place. So I know this is the right one that I should be searching for my board on COM3. The upload protocol changes from ESP-PROG to ESP-Tool. ESP-Tool is a Python script that knows exactly what to send over the serial port to get the ESP32 into a programming mode, to upload the 4 different chunks of the memory image, and to do a reboot on the chip after the upload's complete so that you don't have to physically have a reset button or anything on the board. The upload speed, the faster the better, obviously, but mine works reliably at 921/600. And then I can also say, by the way, monitor for the serial messages on the same port as the upload port because they happen at different times in the process, and that seems to work well. And the serial port speed matches what I have in the code for the initialization of the port in the firmware. So, a couple of things to know before you start this. One, I was getting error messages saying I had an MD5 mismatch. MD5 is it's a fingerprint of a file with a unique number that has a bunch of mathematical magic that says this is a fingerprint for this file. So the system does an MD5 process on the firmware that gets uploaded and the firmware as sitting in the chip at the end of the firmware upload. And I was getting a mismatch on this, which meant the upload was not successful. After some extensive Googling, I found a video from this guy right here, and he gives two suggestions. But the heart of the matter is the ESP tool cannot overcome a problem with the flash memory in the chip being kind of in a bad state. So he's got two lines of Python that try to help with this. The first line is basically tells the board to erase the flash. That's like a subcommand in the ESP32 world. Erase all your flash and then reset the chip after. And then you can run this in a command window like I did over here. That's the one right there. Now, unfortunately, this didn't work. And in the guy's video, it didn't work for him either. So what he had to do is this line that says basically write a series of zeros to the entire flash memory. Basically zero the whole thing out. And I also tried that right here. Now, unfortunately for me, that didn't work either, but it worked for him and it worked for a lot of other people who commented on his video. What I found my problem was in the end is my ESP-PROG board was still plugged in, and that was causing some kind of interference with some of the circuitry. As soon as I unplugged the ESP-PROG, my firmware upload worked perfectly. So don't keep your ESP-PROG board plugged in, and if you get MD5 errors, try to run these two Python scripts. The ESP tool script is actually written in Python, so you got to make sure you have Python installed, and you got to make sure ESP tool is in your Windows command path, or you go to the directory where this Python script lives. Okay, with all that out of the way, let's go ahead and flash some firmware. So I'm going to click the upload button here, and we'll watch the process. Okay, since I don't think I changed the code since the last time, it's going to go straight to the upload on COM3. It's writing the chunks, it's resetting the chip. We didn't get any errors. And I'm going to go and flip over to my phone recording and we'll see what happened. You might have noticed during the firmware upload that those two LEDs were furiously blinking while it was happening. Those are actually showing the transmit and receive data indications of ones and zeros going through the UART chip coming from the USB-C connector. That doesn't happen by default. You've got to go in and use this tool from Silicon Labs called Simplicity Studio. Now, this is a staggeringly complicated tool, but we're only going to use a little tiny part to light up those LEDs. What you do is we click out of here, you go File, New, Express Configurator Project. You click that. Then you get this. Basically, you have some metadata about the device. I changed the product string, as you can see here, EV fuel gauge USB-C port. That's supposed to show up when you plug the device into another device. It will pop up that as the ID. Then what you do is you scroll down to this part right here, port configuration GPIO. Now the two pins that I attached the LEDs to are GPIO 0 and GPIO 1. By default, no current flows through this thing. You've got to use this tool. For GPIO 0, you select TX toggle. Normally it says GPIO 0 like this. For GPIO 0, you say TX toggle for transmit. GPIO 1 is RX toggle for receive. Then you go down here and you click the save button, and we should be okay to do that. And then we say program to device. And then you select the device ID that pops up, and this is the one we want. We hit OK. And it desperately tries to update the internal configuration of that chip to blink the lights in the way we want to. All right, now let's go in and we'll change the flashing just to show that everything still works. I'm going to do a save, and we'll do another build and upload, and then we'll watch to see the blinky light go much, much faster with the click of a button. All right, now let's discuss the last way that you can push firmware to your board, and that's using only the power of radio waves and not a single cable in sight. And this is called an Over the Air update, or OTA. It does depend on your board being able to log into a local Wi-Fi network. The first time you do this, you need to push a new version of your firmware to your board using a cable. So you would use the serial port as we used in the last example, or you could use an ESP-PROG board. But you will need to do this once until the board has active Wi-Fi code running on it. Now, one preamble before we start getting into any code is you have to create a PlatfomIO user ID and log into the tool with it, so when you start trying to push code wirelessly over the air, it knows who you are, and it's a certain level of authentication and authorization. So what you do inside PlatfomIO, you go down here in the corner, you click the little house icon for home, and then you click the little person icon here, and you either log in with your existing account or you create a new one. Don't ask me how long it took me to figure this out, because this is not well documented. First thing you do is you set your upload protocol to ESP-OTA, and you set your upload port to the IP address of your device on the network. It should already be on your network, and you should be able to look at the IP address from your network router, and mine is right here. I'm .116 on EV fuel gauge, so that tells me my board is up and running. First thing you do in your source code is you add 2 lines to pull in the header files for the 2 libraries involved with Wi-Fi, and hopefully we've all done this one before. And then you also pull in Arduino OTA.h. That's it. Now we'll jump down to the setup. And all you have to do is enter a few simple network commands. You call Wi-Fi.setHostname. Now this is optional, but in the list of devices on your network, this board or your ESP32 chip will show up with a gibberish name. So for easy identification, I've just called mine EV fuel gauge. And the funny thing is you have to call set hostname before you call begin. Otherwise it's not accepted. Then once you're connected, you can actually read your own Wi-Fi IP address back and print it out to your serial port. So we are on the network and we're identifiable. Then the next thing all you have to do is call Arduino OTA.begin. That launches a bunch of magic things that happen in the background for you. After you've got your setup line inserted, call Arduino OTA.handle. This means every time through your loop, the Arduino OTA is going to see if somebody's knocking on the door of the board saying, hey, I've got new firmware for you. And it checks every time through the loop. And you want this to happen pretty frequently. If you've got some background processes that are using a lot of CPU cycles and not letting the operating system have control back to run another loop, you may find you have some OTA upload problems. So the cleanest thing to do is have it check every time through the loop. And that's basically all the code changes you need to make. Now, I had some problems with all of this configuration business. One thing I noticed was even if I was trying to upload, I only had upload port listed, it was still trying to go to my COM3. And I discovered that when it said COM3 here next to the little plug, it brings up this box here. And if I entered 192.168.2.116, then it's much more likely to be happy trying to use this as the upload port. So we're just going to make double sure that it's listed here and here. So let's try and do an upload and see what happens. Oh, it looks like it's uploading over the air. Don't fail me now. Stuck at 67. Still working. Oh, upload error. That may be because it thinks it ran out of storage in the flash memory, or it could just be a bad Wi-Fi connection. Let me scroll back and see if there's anything interesting back here when it started the upload. So it's compiling, linking, thinks it's only going to use 58% of my flash memory. ESP-OTA, build options, upload size, sending an invitation to my board, waiting for the device, and uploading. So maybe this was just a Wi-Fi glitch. Let's give it another try. Uploading. I think the board may be wedged, so I'm going to reboot the board and then we'll try yet another upload. Well, the hardware gods have frowned upon me. In the middle of doing that flash update, the board locked up. I came over here and the power supply light was not working. So I thought, okay, maybe the little 12 volt wall wart that I was using, I tried it. In fact, I changed the wire, and it was the 3 volts was actually blinking on and off, which is totally weird. So I thought, okay, maybe the chip is now with the Wi-Fi running, it's drawing more power, and this one can't keep up. So I hooked up a really beefy 12 volt. It's capable of producing 5 amps. But the board's only going to draw what it needs to draw. So I plugged it in, turned it on, and you may be able to see there is now a little ventilation hole in the top of the 3.3 volt power regulator, voltage regulator, when I put the jumper across here to put 12 volts through the system. this thing started pouring out smoke, which is disturbing. I don't know why it would do that. There's like, I didn't change anything in the hardware. So it's getting late. I'm gonna just put everything here to bed and sleep on it. I'll replace this in the morning, and we will see what else is happening on this board. Hey, this is editing Mike from the future. I'm skipping over a bunch of hardware issues, and I'm going to split that out into a separate video to allow the experts out there in YouTube land to have a crack at figuring out what is wrong with this board based on the symptoms you see that I'm highlighting. So we're going to skip ahead now to the point where I've installed the third ESP32 module in place, and I am preparing to flash new software into it. So let's pick it up from there. And I'm relieved to say that after a few tense moments with PlatfomIO because of error messages in the upload, we now have Blinky running on the new ESP32. So we're almost back to where we were before. All right, I've successfully pushed the Wi-Fi version of the code, and we know that's working because I'm at 145 and I'm going through the loop. All we have to do now is go back here and change our upload strategy, change it from the ESP-PROG board, comment all this out, then I uncomment this, and we should be able to push a new version of the firmware. Okay, all the ESP-PROGs commented out. I've got the OTA stuff, plus I'm still monitoring over the USB-C port, but I'm not delivering any power through that. I went into the main and I aftered this after OTA because the Blinky doesn't work on the board anymore. So we have no way to know if the code actually worked. So let's go ahead and build and push, and hopefully we'll see the OTA get all the way through. Here we go. Upload error. Oh, you know what? It's because up here I'm supposed to type in the IP address of the board. I forgot all about that. This is not helpful that it's not reading this. Custom. Okay, we are now going to try to push to its IP address, so let's give it another try. Should skip over everything in the build, hopefully. No, still trying to look at COM7. I commented out our monitoring on COM7, but I don't know how we're going to be able to see if anything happened. It's still here at 145, so let's try again. Here we go. Oh, it's going! 10, 20, 30. This is real speed. This is not me speeding up the video. 50. Come on, we can do it. 60. 70. We're past our previous failure. 80. 90. 100. Result okay. Success. All right. So now let me go back and set my monitoring port back to COM7. See if I have to do this, and then I'll go down here and select this. Yeah, you go ahead and rebuild yourself. So it looks like this is a shortcoming in the upload port over IP. You cannot also specify a monitor port, even if you happen to have a serial port there. So I'm going to go up here. I'm going to pick COM7, and we're going to click here for monitor. We're rebooting the chip. Ah! After OTA, we did it! I can't believe it. All right, that's cool. Now, I'd normally wrap this up, but I have one more thing to try. Andreas from Switzerland has a way to receive the debugging messages over IP back into a terminal program. So let me go ahead and make those changes, and we'll see if we can actually make this all work. Now, the output's not going to come here. It's going to go into Putty, I think, which will have to run in a separate window. But it's worth a try for completeness. Okay, this is going to be pretty straightforward. There's a library called TelnetStream. You include telnetstream.h at the top of your code, and then you go down at the bottom of your setup routine, and you add this statement, telnetstream.begin. Then in your loop, instead of serial, you call telnetstream.println. Okay, so that's as far as you need to go with the code. So you're going to have to decide if you want serial or telnetstream in your debugging, depending on what cable you're plugged into or if you're doing an over the air. Then the other thing you have to do, obviously, is pull in this library. Now in PlatfomIO, I came across here to project tasks. I click libraries, and in here I search TelnetStream, and it's the very first one that comes up from Juraj Andrassy. It's very cool of him to contribute this technology. We add it to the product with this. I have to choose a project. Where's Blinky? Right here. We add it. Okay, everything is being updated. Okay, now we should be able, I'm just going to try and build the code first and make sure it compiles. Ah, you see it added the library here. We got an error in the code. Well, I looked at the library in GitHub, and 8 other people have found this same problem with no resolution. So what we're going to do is we're going to go back to the 1.2 branch, because a whole new bunch of stuff was added in 1.3. We're going to drop back to 1.25. Hopefully this is what I'm asking it to do. Okay, it's rebuilding. Let's give it a second. Okay, it thinks it's rebuilt, but I'm going to change this because it doesn't always work exactly the way you think it should work. All right, let's try another build. All right, I'm going to try one more time. Somebody in the GitHub comment said they got a clean build with 1.2.4. So let's save that, and we'll try a build after all the metadata gets updated. Okay, here goes another build. Let me try this. We'll search for it and see if I can force it to download 1.2.4. Okay, there, 1.2.4. So select Blinky. Let's see if this makes any difference to the metadata of the project. It's almost as bad as Android Studio with all of Gradle doing its magic that you literally have no control over and cannot fix without 1,000 Google searches. All right, are we there? Let's try build. All right, it built. Now we're going to do an OTA. Okay, we started our OTA. Okay. Now I should reopen my Putty and try and open this again. Restart session. Oh, look, 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 look. All I had to do was click restart session. Can you guys see that the text is so small? We're getting it. It's coming through. Top of loop after OTA after TelnetStream. So we are grabbing the serial output through this library using Putty with its ability to telnet into the destination system. So we're telnetting to get our serial port. I wonder if I can somehow get that to redirect into here. That may be some sorcery inside PlatfomIO to tell it to watch for an IP address and a port number. But that's a task for another day. So we've successfully got OTA working. We have successfully got updating over the COM port. And we have successfully got our debug stream coming through. So that gives us some more tools in our development. Next video, which is going to take a while, is going to be me taking all the functionality of the board that's running in my car right now, plugging it into this shell that we have here, and then adding a menu system, web-based menu system, for me to be able to update all of the configuration numbers that the board needs to know in order to properly operate in your vehicle. It's all about the voltages and calibrations. So let's wrap this up. Enjoy the rest of your day, and I'll see you in the next video. Before we wrap up, I'd like to thank my Patreons and YouTube members, Peter Bouvier, Puppy, and Craig, for their ongoing support. I see that a whopping 96% of my viewers are not subscribers, so please go ahead and click that subscribe button because it really helps out the YouTube algorithm. Thanks, and take care, and I'll see you in the next video.